Hello viewers, welcome to my channel. My name is Timothy Kwebelen. Today I'm going to be talking about pharmacogenomics, the feature of coronavirus care. Coronavirus, I don't mean to scare you, neither do I mean to intimidate you with the word coronavirus. We all know that the whole world is terrified by this pandemic. We also know that the whole world is under lockdown by the threat of the coronavirus. I would advise you to stay at home, do the necessary things, wash your hands regularly, and when you sneeze, you make sure you cover your nose, and all the things that you were told about coronavirus so that we do not spread it among ourselves. But I'm going to be talking more on this coronavirus and in relation to what pharmacogenomics means to us. What does gene mean? I mean, when we talk about variability in drug response, we different individuals, we are created the same, but we have about 99% resemblance in DNA and about 98% resemblance in DNA, but with about 2% variance in DNA. So what am I going to say? I'll go back to the definition of pharmacogenomics, and I say pharmacogenomics is the general study of many different genes that determine drug behavior. The way a drug acts on one individual is different from the way it responds to another individual due to our genetic inheritance. And that goes to show that most medication exhibit wide interpatient variability in their efficacy and in their toxicity. And I say efficacy is the maximum response of a drug. It's called the Emass, which a drug can exhibit. And potency is the ability of a drug or the measure of a drug to deliver its therapeutic effect on a human being. The ability is like a measure of that one, the measure of that drug that is bit based. So in a most medication, inter-individual differences are as a result of or parts due in polymorphism in gene encoding drug metabolism. This is how does gene encode drug metabolism? Yes, drug metabolism matters. When you take a drug, there are things that metabolize your drug. There are some key enzymes in people that metabolize the drug we take. These key enzymes that metabolize the drugs have variability. When I say variability, it shows differences. They are different. There's a difference between the way drug respond in my body and the way the drug respond in your body due to genetic inheritance. So that's where what will lead us to this polymorphism in genes, including drug metabolism enzymes. So it's your gene that encodes these drug metabolism enzymes. So when you take a drug, the drug acts on the DNA, and the DNA encode what? Passes message, when I say coded message, to the enzymes in the body. And it's in these enzymes that there's what we call target transporters. These target transporters are what takes the drugs to the target receptors, to deliver the drug to the target receptors. So when a virus enters into a human being, this virus, what it does is to capitalize through its way of maneuvering and getting into the DNA of the host. Because I'm going to be talking about viruses, but before I get to the virus, and I'm going to say what the drug does. When it encode, what it does is it will encode this RNA or whatever DNA it has into the human genome and begin to manipulate itself. And then you have replication, viral assembly, and from there people begin to develop illnesses. So when you say drug metabolism, drug target transporters and drug targets. Polymorphism of drug metabolism is alteration in drug metabolism. So the way an individual reacts to drug is different from the way another person reacts to drug. That's in drug response. There's a variation a variation in drug response among individuals. There's a variation in enzymes, in target enzymes, and implicated enzymes that does what? That metabolize drugs. So, for instance, in China or Asian descent, Joachi Azuma has, in her article one time ago, through her studies, proved that most Asian people of Asian descent are sensitive to a very small quantity of alcohol. For instance, a Chinese person will now do what? Has an enzyme, a deficiency of enzyme that metabolize the alcohol, the absence or variation of these metabolized enzymes that's implicated in metabolism of the drug. So when they take it, then what do they have a more sensitive effect than more. They become intoxicated more. Like a glass of beer can intoxicate the Chinese person, whereas about 12 pints of 5 pints of beer might not intoxicate a Nigerian or a British person. Also, there's a wide variability in drug response. For instance, Africans, race matters in drug response. And the way Africans react to drug sometimes is not the way the people from the whites, black Africans, react to drug differently than the white people. So the white people react, about 3/4 of black people, white people, show sensitivity or reaction to a particular drug. And about half of Africans also show variability in drug response. What am I talking about, and how are we going to connect this pharmacogenomics into the feature of coronavirus cure? We're going to correlate it. We're going to collect it and link it together, because what it is a feature of viral and other pandemic cure, and the future one that might come up, depends on gene technology. Human genome, when we talk about human genome altogether, it is expected by this age that every human being must have a record of his own genetic inheritance, his own gene. Because if genes are stored together, then it is quite easy for a doctor to be able to prescribe a particular drug that can cure a disease. For instance, this coronavirus is a virus. Some people, they have mild reaction, mild symptoms, while some people have serious symptoms that kill them. Some recently has been proven that kidneys are affected, that coronavirus has the ability to pack up the kidneys and also affect the liver. In recent studies have shown most patients dying because of complications. So, and that means some patients are not having this liver, their liver being packed up. That means that even the same treatment that is being given to them, there are also wide differential, variant difference in how this drug metabolizes in their body. So, coronavirus will target, if we have genes stored where anybody, we go to hospital, doctors will be able to prescribe a particular drug that can cure that particular disease. In other words, if we have coronavirus here, and a patient is infected with coronavirus, and he has his gene or her gene stored in the gene bank, the doctor, medical practitioner will know, based on the particular therapeutics or the particular drugs they are using, to be able to know how much is going to prescribe according to what the enzymes or the target enzymes or implicated enzymes in drug metabolism can take. Some patients with less or absence of key enzymes, like I said, about 98% of human DNA looks alike, while some less than 2% of this shows variation. So in these 2% that show variation, they can easily be overdosed. That because there's no key enzymes like enzyme P450 that can be able to metabolize this drug quickly and be able to take it out of the liver. You know that when these enzymes, liver, key enzymes of these enzymes are able to metabolize this drug, so and do what? And let it for excretion. Whereas these drugs, in other way, if you show absence of key enzymes, you will not be able to metabolize quickly, and therefore the person will be overdosed in that particular drug. So in this way, we'll be able to avoid overdosing, and some wide side effects. Side effects also matter. So when we're looking at, say, um, polymorphism or drug metabolism is alteration in drug metabolism which alters efficacy. It alters the mass of a drug, how the drug will react in the maximum response of the drug. It also alters the potency of the drug and the toxicity in the drug. So coronavirus cure direction, pharmacogenomics holds the key to coronavirus cure. Reason, a better gene testing data bank for all individuals will reveal variation in individual response to drugs. Individual variation in metabolism enzymes, deficiency variability in the DNA not include metabolizing enzymes can make a corona patients not to respond to treatment. So inability, since there's a variation of variability in the DNA that includes metabolism enzymes. You know, the DNA that I said it before, that include metabolism enzymes. Once there's a variability in it, this DNA will not be able to do was include the metabolism enzyme that can make the corona patient able to respond to therapeutic drugs easily. Right now, there's no particular drug or viral drug. Vaccines are under clinical trials. There has not been proven drugs. So the work we are using is drugs that are in existence, antiviral drugs. So we're looking into antiretroviral drugs and other antiviral drugs that can be used to cure coronavirus. And everything depends on race. Race plays a major impact on the response to drug. So when we talk about race, for instance, come here, when you talk about race, you talk about immunity in the patient. How is your immunity? Some people that have underlying illnesses like diabetes, like HIV, like all these kind of diseases are more prone to have a more serious effect on coronavirus. Age, race. So both immunity, race and age are part of the thing, but the polymorphism of drug metabolism is also a major part of this. So ethnicity differentials, that means variation or variability in ethnicity can also affect the drug response apart from polymorphism of drug metabolism. So why are we failing to get a cure for coronavirus? We fail in getting a cure to coronavirus because our individual genes are not stored in the bank. Take a look at Africa. In Africa, they don't have a complete database. Talk less of having a genome bank. And therefore, there's no way you'll be able to know a particular drug that you can tailor to a particular patient. Most, not relating coronavirus individual variation in response to drugs. The world is focused on getting a vaccine and have not looked into polymorphism of drug metabolism and not correlating or connecting polymorphism or genetic tests into a way of finding a cure for coronavirus. Because there is no wide test on genes, hence little is known about differences in individual response to a particular treatment. So we cannot, because we're not doing gene testing, we are not able to know exactly how this drug will react to you. And when you have the absence of these metabolizing enzymes, the thing is, for instance, the liver enzyme, one of the benefits of this polymorphism of drug metabolism, which is another pharmacogenomics, is that liver enzymes, through pharmacogenomics, we're able to study liver enzymes and its ability to be able to metabolize drugs. So the drugs that people who have active metabolizing enzymes and will be able to tailor a particular drug to them that will cure them easily, that the drug will be able to give a maximum response. While people, through pharmacogenomics, we're able to know people who have absence of metabolizing enzymes and we're able to know how exactly we're able to treat them, in particular, know the particular kind of dose of a drug that can give to them. So coronavirus, like I said, deficiency variability in DNA that include metabolism enzyme can make a corona patient not to respond to treatment. Apart from immunity, race, age, Polymorphism or drug metabolism is a target to key enzymes, which will reveal drug response. So when we're talking about these key enzymes, I say millions of patients get pain relief through codeine. You know, codeine, some people get codeine relief. When they take codeine, they get a maximum response relief. But why some people have said that when they take codeine, they do not feel, they feel less relief of the codeine. This is because of the key enzyme, the isoenzyme CYP2DC, and which cannot make codeine or bring codeine or convert codeine to its active form. So when they take it, because of they have a variation in, they lack this CYP2DC enzymes, which are key enzymes. So when they take codeine, because they don't have these key enzymes that can convert the codeine into active morphine, the active form, which is morphine, it cannot convert it. So in other words, they have less effect response. So aspirin and dozens of other drugs also, like I said about Africans and Europeans and white people. Africans also develop illnesses that have side effects. African and dozens of other drugs have enormous side effects in patients from African, Asia, and South America. So most patients of these countries tend to get hemolytic anemia as a side effect of this aspirin. So people in Africa than their white counterparts. The white people take the aspirin, they don't get anything like hemolytic anemia, but it's a major thing in African and Asian and South America. People exhibit a response, side effect. They get side effects, and sometimes they find serious side effect out of aspirin. So this is what pharmacogenomics can help us to find generally. So humans have more than 99% of the DNA in common, but some number of interpersonal DNA variation lead innocuous but visible differences. So some people have 99%, they say, but 1% of, or less than 1% of the entire population have what? Variation in their DNA. So that means a particular dog might not work for them, they might have a fatal reaction. That's why these drugs are tailored for them. So if the doctors and researchers will understand that in coronavirus, if we're able to get a cure for coronavirus, we must go back to pharmacogenomics, we must go back to genome and gene study. We must be able to know how drugs behave in our human body according to individual differences and variability. That's why some people are having mild effect. They go to hospital, within 2 weeks they are discharged, while some other people are dead and put under ventilators, and from ventilators they don't make it again alive because of variability in DNA differences, because of variability in enzymatic in key enzymes. These are what we call, and because of these key enzymes affect the metabolism of drugs, that's why there's differences, and this is why we call polymorphism of drug metabolism. This is a major part. It's not something that can be taken for granted. If we were to get a particular drug that tailored to each particular patient, we'll be able to get a particular cure for a particular disease. So, and also polymorphism of drug metabolism also in cancer patients. Some cancer people have cancer, breast cancers, while some of them have some genes in them that can cause cancer. That's diseases. You know, some people will go for a gene test and the doctor will be able to find out that they have a particular enzymes or a particular gene, a defective gene that can create cancer in the future, in their lineage, and they will be able to do what? Start treatments earlier before the time, and that way they will be able to avoid cancer. So in summary to what I have just said before I conclude, I say that pharmacogenomics is a general study of the many different genes that determine drug behavior. I also said that most medication exhibit wide interpatient variability in their efficacy and toxicity. Efficiency, potency, and toxicity. And I define efficacy as the maximum response of a drug. And I also talked. I also talked that in most medication, inter-individual differences were as a result of polymorphism in genes, including drug metabolism. When genes encode drug metabolism, which I explained to you earlier, it affects how the enzymes and drug target transporters take the drugs to target cells in the body. I also talked about efficacy, potency, and toxicity in drug. I also laid emphasis on coronavirus cure direction and why pharmacogenomics hold the key to coronavirus cure. I also talked about the reason why a better gene testing is needed and why the world should go into genome generalization, where countries will be able to have a data bank of their citizens' genome individually, so that there will be a better drug design. It is true how your gene responds to drug or absence of enzyme or what is in your gene that will make researchers to be able to design a drug, particularly for a group of people or a race or a particular people that shows variability to a particular quantity or amount of drug that will be given. In that way, their drugs will be tailored onto them. And also, I also talked about implicated key enzymes. I talked about cytochrome P450 enzymes, and I also talked about what enzyme? I also talked about other key enzymes. And that brings us to the end of the course. And I will advise, if you are interested in the topic we just conducted, you can subscribe my channel, and I advise you to subscribe my channel. And I also ask you, there's going to be a bell on the screen. I advise you to click on the bell on the screen, and in that way you'll be able to receive more of these lectures and more of the things according to what is in my channel. Ladies and gentlemen, I just want to conclude all this we have done today. Thank you very much.